So the newest series of Neptune 3 printers are pretty good, and they come with this nice direct drive system. But sadly it doesn't have an all-metal hot end, and instead they decided to use a PTFE lined one, which wear out over time and limit how high of a temp you can print at. So I'm going to show you how to install a bimetallic one instead. And surprisingly, you can do this for pretty cheap, seeing that you can get 4 of these for about $12. So the first thing you need to do is remove the 2 bolts that hold in the fan shroud, and then you can just kind of slide this off and kind of fold it down. Be careful of the wires that are attached to it. And on either side you'll unplug both of the fans. And with that free, you can just lay this to the side. And now I need to remove the cable that goes into the assembly, because I'm taking this completely off of the printer. And to do that, there are only 3 bolts holding it on, so if you flip the machine around, you can easily get to them all. So as you can see, it's very easy to take the entire hot end off, and it also makes it easier to work on. That being said, a lot of this can be done with this still on the machine. But anyways, I need to remove this grub screw so the heater cartridge can come out, and you don't have to remove this screw completely like I did, just enough so the heater cartridge can slide out. And you also need to remove the screw that's next to it that's holding in the thermistor. And you might notice that this has a plastic coating on it. This is actually coated in PTFE, which can only handle temps up to 260 degrees Celsius. So if you're wanting to print hotter than that, you're going to want to replace this. And I'll cover that later in this video. And to remove the rest of this, there's 2 more bolts on the bottom and 1 more grub screw holding in the heat break. And with those screws removed, you can just slide this whole part out. And there are parts of this you can reuse, like the heater block and the nozzle. But getting the original heat break off can be difficult, seeing that they used a thread locker on it. And I did try to get this off using a vise, along with a wrench, but it was so stuck in there that it broke off at the threads. So instead of doing that, I suggest ordering a new heat block. And you can get a 5-pack of them for about $9. Or if you want to splurge a little bit more, you can get a solid copper one for about $13. And this is meant to be at higher temps anyways. So our new assembly with the new heat block will just slide in place and the holes line up perfectly. That being said, the stock bolts that held this in place before are a little too short now using this style of heat block. So I got some new ones. They are M2 by 16 millimeters long, and these fit perfectly. But if you're looking for any of the stuff I'm using in this video, I have links to everything in the description below to make it easier for you. And with both of those tightened down, the grub screw is next, and then you can put the thermistor back in place. And when tightening up the bolt on this, make sure you don't overdo it or you'll cut right through the wires in this. And then you can put the heater cartridge back in with the grub screw. And try to line this up as flush as you can with the heater block, and don't over tighten the grub screw on it. So once you have that in place, you're pretty much done with the install, and you just have to put everything back on the printer. And this is just basically in reverse of how you took it off. So the 3 bolts on the back, plug in the main wire and put it back in its holder. Plug your 2 fans back in, and then just put the fan shroud back on, make sure you don't crush any wires, and the 2 bolts that hold it on. So after switching everything out, nothing is going to be in the same spec anymore, so you're going to need to re-level your printer and reset your Z offset. So here's all my new numbers, and let's do a test print to make sure everything is working properly. And after about an hour, it looks like the little test Buddha has finished, and overall it looks like it printed out pretty clean. In theory, this shouldn't really change your print quality all that much, if any. That being said, the test print I did before installing this has some weirdness on the bottom of the model that isn't on the new one. So you can take that for what it is, but at least you can see that the new setup does print. And for those of you that want to print at higher temperatures, don't worry, I didn't forget, and I'm going to show you how to get that set up. And that's more or less why I showed you how to take the entire assembly off, because you can't really switch out the thermistor with it on the machine. So I'm just going to unplug and remove this, and obviously I already released it from the heat block, and I'm going to be swapping in this one. And according to Elegoo, these are the exact specs you need for the printer. And you can tell this one is a little different. It's not glass, it is a brass stud. And its wire isn't coated in PTFE. So the max temp rating for this one is 280 C. And this particular one is almost plug and play, besides the plug being the wrong size. And of course, I don't have any of this particular connector on hand. So I'm just going to do the next best thing and cut them in half and splice them together. And order the proper connectors and put it on later. But this will work for the time being. And this stud is an M3, so it matches up perfectly with the threads in the block. And I just screwed it in as much as I could with my fingers. And seeing that I don't have a wrench this small, I'm going to use some nylon tipped pliers to tighten it up. And all that's left to do is plug it in, route the wires, and it should be good to go. And this wire does stick out a little bit longer than I would like it to, but I'll fix that once I get the actual connectors. But now I can put this back on the machine and make sure it all works. So I'm just preheating the nozzle to 200 degrees to make sure that there's no crazy thermal runaway or anything like that, and making sure that it can keep a consistent temperature. So it was able to do that, so I'm running a test print of the same model as before. And after about another hour, that's done, and it looks like it came out identical to the last one I did, so I think things are working fine. And now in theory, with the right nozzle, I should be able to print carbon fiber nylon with this printer inside of an enclosure, or even ABS at the higher end of its temperature range. That being said, using the screen itself, you can't set it for anything higher than 160. But according to Elegoo with the newest firmware update, you can bypass this using G-code. So when slicing your file, if you set it to 280, it will print at 280, as long as you have the newest firmware update. One thing I didn't mention, and it's honestly because I didn't do it. When installing the new heat break, you can cut down some of the old PTFE tube and reinstall it so you have a cleaner path for your filament to go through when loading it. Well, I hope you found this information to be helpful, and the same technique should work on the Pro, Max, and the Plus. If you have any questions, feel free to leave a comment and I'll try to help you out. And if you haven't already, check out my video on the Neptune 3 Max right here. Well, thanks for watching and see you guys next time. Bye.